Hi, everybody. Data visualization is a very important concept within data science. And I'm going to speak to you about data visualization with Python, predominantly focusing on two very important libraries as part of this video session, covering Matplotlib and Seaborn and the usage of this. Hi, this is Kamal, and I am co-founder at AccelerateAI. Let me walk you through what we want to cover today. So our agenda is to focus on, first, we'll talk about the motivation. Second, we'll focus on the various packages in Python that are explicitly used for data visualization purposes. Some of the important ones, we'll focus on that. Then we'll be getting deep dive into Matplotlib library and also into the Seaborn library. These two, and we'll try to compare. And then, of course, the key takeaways at the end of it. So let's get into it. First of all, when we look at motivation towards what is the need for our data visualization or the exploratory data analysis process, the business objectives are many. And based on that, what type of charts to be used and what type of color combinations and different aspects have to be followed are to be kept in mind. Now, the purpose or objective can be many. If it is around distribution, then we'll have to look into something like bar chart kind of representation or histogram or stacked histogram, box plot, violin plot, density plot, and so on. These are just a representative list. There could be many more as well. The purpose or objective can also be composition, where we are talking about a part to whole kind of representation, and which is where we can use something like a waffle chart or pie chart or tree map. And of course, bar chart and different representations of bar chart can also be used, provided they all stack up to 100% in the part to whole scenario, in the composition kind of need. Next, the correlation or relationship. When we are trying to develop that between variables, then we can probably use scatterplot, correlogram or heat map kind of a chart, pairwise plot, scatter plot with logistic linear regression, bubble plot when there are more than two variables. Two variables is for the scatter plot and so on. If the objective is around comparison, then we'll have to look into multiple time series kind of chart or bar chart with different categories of interpretation and demonstrating those as a comparison view. There could be stacked bar chart or histogram showing the differences. There could also be grouped bar chart and radar chart as well. So essentially, these are not all. There are also ranking and different type of grouping objectives that we can have and different type of charts that we can use for that. But these are predominantly the more common, more used ones. Now, if we get onto various packages in Python, then we could see some of the important Python packages would be Matplotlib, Seaborn, Pandas, Plotly, Bokeh, Altair, and so on. If you look at Matplotlib, it's one of the most powerful libraries, and we'll talk about that. Seaborn is also very simple and easy to use. We'll see the power of it. These two will be covering as part of this video session. At the same point of time, I would like all of you to also take a look into some of the other ones like Plotly, which is great for collaboration purposes. Bokeh is also great for interactivity, intuitive charts. Altair is more from declarative statistical visualization purposes. PyGal, we can use it working with some SVG images, scalables, vector graphics images. And then ggplot2, the grammar of graphics, can also be used in Python, like the way we use it in R predominantly. And of course, geoplotLib. Now, this is again a non-exhaustive list. There could be a lot of other packages as well, but these are more prominent one and commonly used, out of which we'll focus on Matplotlib and Seaborn as part of this video. When we look at Python visualization landscape, here if you see, Matplotlib is pretty much a more predominant and a more primary package, as you would see, and a lot of others are related to it. For example, Seaborn, as you would see, is on top of it. It's an arbitrary package on top of Matplotlib, but the core one is Matplotlib. Similarly, you could see Plotlib, okay, there's on the JavaScript side of it, usage of that, OpenGL for other purposes, and then associated libraries. So similarly, the entire presentation of Vue, you would see different type of charts or the libraries represented here. Here, we are going to focus on Matplotlib and Seaborn. Matplotlib was created in 2003 as part of SciPy Stack, which is an open source scientific computing library. It's most popular, it's been widely used and extremely powerful as part of all the data visualization packages. It gives a greater control on the charts to the user and the developer who is using it and developing, writing some of the code snippets. But at the same point of time, yes, more coding is required as part of this. If we look at basic plotting, it's a comprehensive library, and then initially you need to have something like matplotlib.pyplot that you're going to import into your notebooks. And then, of course, if you're using a Jupyter notebook, then you have to use percentage matplotlib inline, specific command that lets you see the plots in the notebook itself. If we take an example, the PLT object that we have imported and called as PLT object, matplotlib.py plot. If we try to get a list of 4 or 5 values, here we have shown that in the plots. Very, very simple way of representation of the plot using these commands. Similarly, if we want to draw 2 sets of points, here, if you see there are 2 sets of points, and one representing a green dot and a blue star. And these are all the syntax GOB star representing green dots or blue stars. Similarly, G hyphen, a lot of other things can also be used. Next, of course, when you look at creating figure and subplots, the way we can create figure and subplots is we have to use something like say y equal to true, and then we want to categorize into AX1, AX2, 2 different plots of x's. And then setting say y equal to true in the plt.subplots will give us 2 subplots in that. And the output would be something similar to this. So in the previous slide, we were seeing the green dots and then the blue stars are represented in one particular figure. Now here, we are kind of separating it into 2 subplots, and this can be represented in this way. Now, if we want to draw multiple plots, and then let's say we can leverage something like a same PLT subplot, but 2,2 with kind of a 2 by 2 matrix, 1, 2, 3, 4, and then we can say x equal to true, y equal to true, and accordingly we'll be able to see this representation 4 subplots we can see in one figure in this way. Right? So typically the life cycle of plotting using Matplotlib, we can go through this. We'll get onto a quick demo to walk through a notebook, understanding of the packages and basic plotting, then creating of figures and subplots, how we can do that, drawing multiple plots, then changing some of the axis text positions and levels. Then we need to understand the usage of RC patterns, color, plot styles, different type of those annotations. Customizing the legend, how can we position the legend in a different place? Adding texts, arrows, and annotations. Then, of course, scatter plot, histograms, and of course, plotting 2 y-axis representations in bar chart. So let's get on to the demo quickly. I will share the notebook now. So here we have a notebook where we wanted to show you the visualization using Matplotlib. Import packages and basic plotting. This is what we were mentioning about, matplotlib.py plot as PLT. And then also we are using a func formatter as a ticker object from here. And then you can check the methods under PLT by using a command dir in parenthesis PLT, dir in parenthesis PLT. So it will give you all the methods under this particular PLT. And then when we want to plot, this is what we were mentioning about. You just give the list of numbers and it drew a line chart automatically. It assumed the values of the x-axis to start from 0 and go up as many items in the data set. So it defaults that way. So if you mentioned 1, 2, 4, 5, 8, it assumes that it starts from 0 and x-axis and goes from that way, and it represents accordingly. You can also do help plt.plot to be able to see a lot of different type of annotations that we were looking at, right? GO, G star, BO, B star, B minus minus, and all that stuff. See here, if you look at GO stands for green dots, and exactly this is what we were talking about. And if we want to add another set of points, so there are two set of points, GO and P star, and it's represented in a XY plane axis. Then if you want to add the X level and Y level, we want to ensure dot X level, dot Y level, and whatever value that we give, it creates the X and Y level for it. We can also mention the legend. Location is the best. So legend text comes from the plot's level parameter, and then accordingly we can show that. And also it's a good practice to have the title always mentioned, so we can always mention the title of your plot. Now we can change the size of the plot. We can always do, plt.figure, fig size 8,5. 8 is the width, 5 is the height. You can change with, you can play with it, 10, 6, 12, 7, whatever, based on your size and the requirement. Then getting onto the figure, creating the figure and the subplots. When we look at the subplots, we have seen that here we are actually representing green dots and blue stars, these two things side by side. So essentially you would see plt.subplots 1, 2, right? 1 by 2. So it's gone divided into these two, which say y is equal to true. So essentially the y-axis is shared by two set of values that we want to represent as different plots. Multiple plots here, 2 by 2. And of course, say x true, say y true. And then of course, you can give all of these details to be able to see x0, x1, x2, x3. Now, how to change axis text positions and levels? There are three things in Matplotlib when it comes to manipulating the axis text. How to control the position and tick levels that you need to look at using the plt.xtext or ax.setxtext kind of a command. And then, of course, how to control the axis text, top, bottom, or left or right. That also can be done using something called as tick_params. plt.tick_params. So essentially, we are writing radian to degrees kind of a function here, and then using some of the numpy's objects to adjust our x-axis and x-axis ticks, and then the tick parameters, and then it kind of positions and creates the sine and cosine waves for us with 90 degrees, 180 degrees, 270, 360. So we have kind of created this as part of representation of this visual on the plot. Now, basics of RC params and colors and plot styles. If we want to do import Matplotlib as MPL object and then say RC_params, then you would be able to see what all different type of RC params can be there. Now, the look and feel of various components of a Matplotlib can be set globally using this particular parameter, which is RC params. Okay. And the complete list can be viewed with when we do this import Matplotlib as MPL, MPL.RC_params, that will give us these details. We can also see a Matplotlib with the style that are available. For example, plt.style.available. It'll give all the pre-built styles like this, classic dark background, Seaborn bright, Seaborn dark, and so on, right? Now, if we want to kind of plot this, different type of, usage of the styles that we are talking about, we can do that by using the similar notations. And here you would see Seaborn notebook style is this, ggplot is slightly darker, BMH is another one. So these type of ways, the colors and then backgrounds and a lot of other things can be controlled. If you want to view the colors, then you can say mpl.colors.css for underscore colors. There are 148 colors that will be shown here. Then there is also plt.cm. If you use that, then you'll be able to see some of these. So colors combinations also can be looked in. When we want to customize the legend, then we want to make sure the positioning of the plt.legend, we can modify it. The default is there, but then we can modify it by saying, the legend border frame on equal to true. Then we can say the legend border, then frame alpha equal to 1. It defines the transparency of the border of the legend. Then n col equal to 2. There are two columns because we have sine curve, cosine curve 2, cosine curve 2. So we want two columns to be represented here. Then shadow, if we want to say true, then shadow is on. Then this entire thing can be shown a little bit of shadow here. And then thickness of the border, we can define that, and title also we can control it. So plt.legend would provide, to modify us the legend values. The default will be there if we don't specify anything explicitly. However, this can be used accordingly. Then adding text and arrows, annotations, you can use plt.annotate, annotate with arrow props and bounding box. So if this kind of a graph, and then you want to sine wave, cosine wave, you want to see this is the pic, you want to use that kind of a text, then you can always use plt.annotate. And then these are some of the parameters that you can use, and accordingly this can be modified and used. All of these. Then we have a scatter example with varying size and color of the points. We have taken a sample data set, and we wanted to use that plt.scatter to be able to plot a scatter plot here, which can be used. But as you would see, there's a lot of things that we want to mention, highlight, the title, the X label, Y label, the color bar, all of these. And in the plt.scatter, we have given the parameters of all of these information in this graph. We can change it by providing some of the different values, variations to it, and accordingly, we can save that particular bubble plot that we have created and seen on the top. Similarly, we can plot histograms, box plot, time series, all of these. Now, if you want to do and represent all of that in one particular place and kind of position that, then you can set up your subplot grid layout accordingly. So subplot grid layout, as you would see here, 0001, 0203, 10 with call span of 2 given there, then 1213. So essentially, if you look at here, 1, 2, 3, 4, and then time series as second, 5, 6, and then box plot and histogram 7th and 8th position within the grid, right? So you have a scatter plot, step plot, bar chart, fill between graph, time series kind of a plot, box plot, histogram, all of these, if you want to display in one particular grid with 4 by 4, 8, and whatever structure, accordingly, you can specify the subplot to grid kind of a layout here. And then we can fit in all our charts that the way we want to demonstrate there. If we want to have plot with 2 y-axis representation, that also we can do. We can take a sample data set here. You have the sample data set. And then what we want is we want to kind of have, this is your y-axis of personal savings rate and also the unemployment values. So there are 2 y-axis represented in the same x that can be done. So personal savings rate versus unemployment rate, you can actually plot it in the primary and secondary y-axis and compare it how it is. So those type of things can also be done. We can use with the data set, we can use AX1 and AX2, but what we are doing here is plotting the line 1 on the left y-axis. That is fine. We can use it with subplots. But on the line 2, the right y-axis, we'll have to say AX2 equal to AX1 dot twin x. So it instantiates a second axis that shares the same y-axis. That is how this is represented, and accordingly, we can use all of the decorations alongwise. We can use a bar chart as well, looking at a particular UK elections result data set as a sample. And then we can initialize a figure of the subplots. Then, are our data representation here. Then we can plot each of the bar plot accordingly, manually calculating the dudges of the bars. And then, we can give the level color accordingly, and then that can be represented. So ideally, if we summarize, we can use Matplotlib in this way. We'll see Seaborn in a minute. But this is very powerful because you have a greater control, and you are also able to change some of the layouts appropriately. You can control it in an effective manner. But yes, one of the downside is, you have to write a lot of coding. You have to understand each and every aspect to be able to write that down for your plotting. Now, let me go back to this, and we'll move to Seaborn. Seaborn is essentially an abstract layer on top of Matplotlib. It's a simpler one. It provides a neat surface, and it has got wide range of plots. It can be created easily. Very few lines of code. We'll see the demo shortly. And with appropriately less coding. That's the difference between this and then the Matplotlib. Typically, the plotting organization with Seaborn, if you look at, one is relational, second is distributions, third is categorical. There are different type of plots for the purpose of these. Rel plot or relational, where scatter plot, line plot related charts that we can build. Dist plot for the distribution purposes. You have history plot, the density plots, and so on. Categorical plot is like you have the strip plot, swan plot, box plot, and so on. So let's quickly get on to the demo again for Seaborn. Now, Seaborn, if we look at it, as you'd see, as the chart gets more and more complex, the more code that we have to write in Matplotlib, right? And there you would have noticed that there is no direct method to draw a density plot of a scatter plot with a line of best fit, right? That is very, very difficult. So what we can do, instead to use a higher level of package like Seaborn, we can use this Seaborn for some of its pre-built functions to draw these kind of charts. We're not going to go in depth into Seaborn. However, we'll try to see some of it, and the plotting organizations I was mentioning about already, about relational distributions and categorical, and we'll see. We will import packages in basic plotting. It happens you'll have import Seaborn as SNS, and of course others are as is. Then you can always do, there are some generic data sets which come along with it. And when you print sns.get underscore dataset underscore names, you'll be able to see a lot of these sample data sets which can be used for learning purposes. So we have used a car crashes data set here. We have loaded that. These are all some of the values. And if we start looking into a scatter plot between the speeding value and the alcohol consumption value, then these two parameters can be plotted. It's kind of a scatter plot. Then we can look at the rel plot functionality. We are using the tips data set here with the total bill, tip, sex, smoker, day, time, size, all of these mentioned here. Now, if you want to use sns.rel plot and data equal to your data frame name, which is tips, you mention the total bill on the x-axis and tip on the y-axis. And if you say hue equal to day, then by day, it will represent this entire colorful. So what we are seeing here is with just one or two lines of code, we are able to achieve some powerful visualizations, which was possible in Matplotlib, but we have to write a lot of code, right? And assigning a column variable creates a faceted figure with multiple subplots arranged in this way, right? So here, what we did, we want to get that split into the lunchtime and the dinner time. And of course, all other remains the same, and this split happens quickly based on that. So if you look at the differences, X and Y axis is the same. Hue is the day that we have already mentioned, but call equal to time is what we have mentioned. And then it splits into two different columns like this. Similarly, different variables can be assigned to the facet on both the columns and rows. Call equal to time, we have already mentioned. Now row, if you want to add another variable called sex, then we would say this is male and time lunch. This is female time lunch. Then male dinner, female dinner. All of these are again segregated and then shown. So just about one parameter, and then we are able to see that quick results and representations. So it's extremely fast and then quick with less coding. When the variable assigned to call has many levels, then what we can do is we can wrap it. We can say call wrap equal to 2. And then what you can see is, lunch, dinner, and then you have day equal to Thursday, Friday, Saturday, Sunday, all of that different type of, levels are wrapped, and then they are shared across and displayed across here. Then we can go a little more complex as well. Multiple semantic variables. We can use some of these sizes 10 to 100, a palette B and blue and red, and then some of these different sizes of it. The moment we display that, then we'll be able to see a lot of these time by size, by gender, all of these by sex, gender, all of these are represented here in that one, in the same scatter plot. We can use other data set like fMRI, where you have the subject, time point, event, region, and signal. And then using kind of a rel plot and with the kind equal to line, we'll be able to demonstrate this. By default, the resulting plot, it will displays the mean or the average, and the 95% of the confidence interval for each unit would be represented here. Then getting on to density plot in Seaborn, we can leverage using KDE plot that we have seen, and we can use the same data sets with data equal to the data frame name, then X, hue, then field equal to true, common norm is false, palette is crest, and then all of these parameters, and then it gives a very beautiful presentation of a density plot. Another similar way of representations of density plot like this, histogram with Seaborn, we can use with hist plot and then create. We have taken another sample data set which comes with SNS, that is penguins data set, and try to represent the histogram here. There are different ways you can flip in the y-axis in this side. Here we have used x equal to the parameter. Here we are using y. Similar way, if we say bin width equal to 3, then we can check how well the histogram represents the data by specifying it, because then we'll have the representation across each and every values. We can add a kernel density estimate, KD equal to true, to smoothen the histogram and provide some complementary information about the shape of the distribution. If we just say about hist plot and data equal to this, then neither X nor Y is assigned. So the data set is treated as wide form, and a histogram is drawn for each numeric column. If we then provide X equal to the parameter values and hue is species, then of course it shows a long form data set with the hue mapping to it. Now, overlapping bars can be hard to resolve visually, but a different approach would be able to draw a step function. We can use element equal to step to be able to represent it this way. Then we can use pair plot to show the relationships. We can use the same penguins data set, sample data set, and then when we are using this, this is the simplest invocation of the scatter plot for each of the pairing of variables and the histogram of it, the hist plot for the marginal plots along the diagonal. So you'd see with just SNS dot pair plot with the data frame name, we are able to achieve and show this. And when we assign a hue as species variable, then we'll be able to see a color-wise changes by layer of the kernel density estimate. So what we could see here is, the Matplotlib and Seaborn are really powerful, and a lot of data visualization we can do using Python. They pretty much cover all type of purposes. We haven't even covered more than 20-30% of here. There are a lot of other areas that we can go through and then use similar kind of representations. But one thing that we have noticed is Seaborn is much simpler, and it's an abstract form on top of Matplotlib. Matplotlib, you have to write a lot of coding, whereas in Seaborn, very few lines of code, and you'll be able to accomplish and achieve much stronger and powerful visualizations. So let me go back here. And if we were to kind of get into 8 key takeaways, right? One, know your audience and then plan for the plots and charts. So it's very important. We need to understand the stakeholders, personas, what they want. Accordingly, we can create appropriate charts using Matplotlib and Seaborn, both. We also have to know the purpose, whether it's for distribution purposes, comparison, we have seen that, group information ranking, and so on. We have to adapt the figure. We have to adapt the figure to a particular area size, and accordingly we can control it. Captions are not optional. Obviously, the x-axis, y-axis, the title, all of these have to be meaningful. Otherwise, the plot doesn't look that great. Do not trust the defaults. So if we need something, then we have to explicitly provide that in the parameters to be able to show our plots accordingly. Use color effectively and avoid chart junk that we know from the concept that we have gone through. If you want to go through the concepts of and principles of data visualization, I'll give you the comments on the comment section of this video about another video that we have already created, and you can go and look at that. Edward Tuftay's different principles that we have analyzed and explained in that video. Do not mislead the reader by providing confusing visualizations. We have to make it crisp and simple. What is the purpose? And accordingly, we'll have to demonstrate that. Get the right package, right chart for right purpose. Obviously, these are 2 examples which are powerful. We know where we can use Matplotlib, some of the cases where we can use Seaborn. There are a lot of other videos where we will talk about some of the other packages as well. Hope you have enjoyed this particular thing. If you have any questions, you can always reach out to us on our LinkedIn page, or our YouTube channel, AccelerateAI. And if you have any suggestions and feedback, please feel free to email us on acceleratedatascience@gmail.com. Thank you.